Reactions in aqueous solution. Acid reactions. 3.2 acids and metals make hydrogen gas and a salt. In this case, we're going to use zinc and hydrochloric acid. Here we use zinc metal. And we're going to put it into a flask containing hydrochloric acid. And immediately bubbles start occurring of hydrogen gas. Now we can see the bubbles coming out the end of the delivery tube, and we fill a 500 milliliter bottle with pure hydrogen. We'll come back to that a little later. And we now collect 3 test tubes full of hydrogen. Now, how do we test that the gas is hydrogen? Well, we ignite it. And when hydrogen burns, it makes that characteristic popping sound when we have a small amount in a test tube. Looking at that in slow motion, notice how the flame jumps into the tube, making the loud sound. Well, what about collecting more than a test tube full? Let's collect 2/3 of a bottle with pure hydrogen and 1/3 pure oxygen. Real rocket fuel. So here we have a Kipp's apparatus. A rather cool apparatus, putting some zinc into it, into the hydrochloric acid, and bubbles occur, building up the pressure in this part, pushing that liquid down and up into the reservoir of the funnel. When we release the clamp, we see the bubbles now coming through into the bottle as the reservoir drops down, bringing the acid back in contact with the zinc. Collect the hydrogen by downward displacement of water. So we put 2/3 of the bottle with pure hydrogen, and the remaining third we'll fill with pure oxygen from the gas cylinder. What will happen if we ignite this bottle? Well, to do that, we're going to ignite it from the far end of the lab. Here goes. Wow! Let's look at that again in slow motion. Real rocket fuel. It sends the space shuttle into space. Hydrogen plus oxygen reacts to form water and lots of energy. What about the bottle that was full of pure hydrogen? No bang. Why not? So what does that mean? Well, the hydrogen's burning in the bottle at the opening of the bottle. It's a slow, controlled burn. It's not an explosion. Why not? Well, you can begin to see that the neck of the bottle is melting. And there you can see the flame is still burning. So the flame can't jump into the bottle and explode because there's no air in the bottle. And so the burning occurs at the opening of the bottle where the hydrogen comes in contact with the air.